This is section 3.9, exercise 2. And in this, they just want us to fill out a table. So we have f of x, and they're calling the tangent line t of x. And everything's around 2, so 1.9, 1.99 to 2.01, 2.1. And let's see, this is number 2, so what we have is our f of x is equal to 6 over x squared, and so they fill in the 2 for us. They tell us f of 2 is equal to 3/2. Now we can check that. All right, that's we should have 6 over 4. And sure enough, that's 3/2. So here we have 1.5. And so the tangent line should also be 1.5, because for a tangent line, we just use a point slope form. F prime of x is equal to, well, f of x is 6x to the negative 2. So this becomes negative 12 x to the negative 3. For me, the tangent line approximation here could be sort of nasty, but the nice part is we just evaluate this at 2 to create our tangent line. So f prime at 2 is equal to negative 12 times 2 to the negative 3, and that's 1 over 8. So this is negative 12 over 8, or negative, really, 3/2. That's interesting with 2, okay. So, right, because that's 4, yeah, I think negative 3/2. And so a tangent line, again, I suggest you write it this way: f prime at some x0 times x minus x0, and then plus f at x0. As in, don't put the y1 over with the y, just put everything over here to the right. Or, in some ways, even better, you could write it this way. It's just not the way we're used to seeing straight lines written. But what we see here is that, we're at x0, and we see that we're using the function value and all that. So now, our tangent line t of x is, so f at x0, so that was 3/2, and then plus, well, actually minus 3/2 times x minus 2. So there's our tangent line, and we can try out some of these other values. 1.9, 1.99, so t of x, so t of 1.9 is 1.5 minus 1.5 times 1.9 minus 2, so that's a negative 1/10, so that's 1.5 minus 1.5 times a negative 0.1, and so that gives 1.5 plus 0.15, and so 1.65. So, we would fill this out at 1.65. I'll do 1.99 and then also check the function value. So 1.99, this is 1.5 minus 1.5 times 1.99 minus 2, so that's 1.5 minus 1.5 times a negative 0.01. So this is 1.5 plus 0.015. So this is 1.515. So, if we come up here, we got 1.515, and at 2, it's 1.5. Okay, so what about the function value itself? Oh, heck, I don't know. Right, f of 1.9 is equal to 6 over 1.9 squared. That doesn't sound like fun. I'm going to put this on pause just for a second while I go pull up Desmos. Alrighty, so I pulled up Desmos, and we can get answers for these two. I'm just going to do these two, 6 over 1.99 squared, just so we can compare those answers. And so when I did 1 over or 6 over 1.9 squared, I got 1.662, and then over 1.99 squared, 1.515. So hopefully I can remember those numbers. 1.662 and 1.5151, I think, was the next number. But you see, these numbers are pretty close. They're starting to get farther and farther away, but not bad. Okay, so that's what they want us to do for number 2, and I could just fill in those as well. But we just want to produce that tangent line, get a tangent line approximation. And, well, what the heck, actually, while I'm at it, let's just go look, since I have Desmos up. Let's insert f of x equal 6 divided by x squared. So now I could just evaluate f of 1.9 and all of that. But now let's also do the tangent line. And so an uppercase T is okay. I wouldn't use a lowercase t, because that might confuse Desmos. But if we do t of x, and we write that as, let's see, equal f. So we do f of 2, and then plus f prime. So f, and I need to shift to get the prime, of 2. Whoops. Didn't mean to do the x there. Of 2. There's f prime of 2 times x minus 2. And so, whoops, that's not what I wanted. There we go. And so we see there's the tangent line, and at 1.9, it's still 1.9. There you can actually see 1.9 on the screen down at the bottom. It's starting to separate, definitely, but it's still pretty close. And if you look over at 2.1, things are pretty close there as well. Okay, so we can graph all that and get Desmos to do a lot of the calculation for us. But there is our tangent line. And I guess, one more thing. I can insert a table, And so, let's see, I need this up. So we have like 1.9 and hit enter, 1.99, hit enter, 2, enter, 2.01, and enter, and 2.1. So I have that, and then if I come up here and I edit that y, and I call it f of x, I can, oh, not f of x, sorry, f of x1. It needs to have the right variable in there, so f of x1, there we go. And so I can do that, and there are my values. And similarly, I can go in here and do my uppercase T of x1. And there are my values there. So that's, it's very simple to calculate all this. And it even plotted a bunch of stuff here for me. And so I can kind of see how they match up. And I can zoom out a little bit. And so you see they match up pretty well in there, very close to 2, but they're starting to split apart out at 1.9 and 2.1. So now I think we can go ahead and say that this exercise is done.